My name is Chris Harper. I'm the Global Product Manager for Fife Inspection, and I'm going to introduce the Veo 600. The Veo 600 system is comprised of 3 camera options. The first is a manual position camera with a keyboard on the front of the camera. An intermediate option, which isn't shown here, which is a manually positioned camera without the keypad on the face. You would use this remote control. Or a motorized system, which just adds the motor to the back of the standard camera and is controlled by the same remote control. All 3 camera options use a common power supply shown here. Each system is supplied with a standard 19-inch LED flat screen. A 24-inch flat screen is an optional purchase. And each system is supplied with a standard gear sensor or pickup sensor, which is this proximity sensor and this mounting bracket. This is the camera supplied with a manual system, Veo 600-M. The keyboard is on the front of the camera. The camera is mounted on a simple extrusion through this mounting hole, so that once your extrusion is mounted between your frames, the camera mounts on that extrusion. There's a lockdown knob on the back here, so that when you want to make position adjustments, you adjust it, lock it down, and you're ready to go. The connection to the camera is on the top through this connection. So the brackets shipped with the system are to be mounted between your machine frames, and once those are mounted, the extrusion and the camera can be slid into that with the screws tightened down to hold the extrusion in place. The brackets are supplied with these curves so that they can be rotated to allow the camera to be flat to the web. So you're looking for a 10mm space between the surface of the web and the camera, and that needs to be level from the front of the camera to the back. Also supplied with the camera is a single cable. This cable goes from the camera to the power supply. It's the only cable that goes from the camera to the power supply. This length is picked when you size the system. It connects to the top of the camera here. For lengths under 24 inches or travel less than 24 inches, this cable will be supplied this way without cable handling. For lengths longer than 24 inches, we'll actually do a cable handling system, which we'll show you on the motorized system. This is the motorized camera for your Veo 600-MTZ motorized inspection system. The camera is actually the same size as the manual camera from the silver part forward. What we're doing is adding this module that has the motor and the gear on it to drive the camera back and forth. This is a proximity sensor. There's one on the opposite side also. This will be your position limit for auto scan. Inside are the wheels that travel on the track that are mounted on the extrusion, and the gear that engages with the rack mounted on the extrusion to drive the camera back and forth. It's the same single connection on the top of the camera. So your camera cable, single camera cable goes here, and then these screws are for securing the cable to the camera. Move this out of the way. The cable is the same cable as on the manual or manual with remote system, except that we're supplying it with this cable chain. And so along with it are the brackets that mount it to the camera as a strain relief. And then on the opposite side where you would connect it to the cable chain tray. So your extrusion, I'll move this out of the way, is going to look like this for the motorized system. You have a main extrusion as your main support. On the front then, mounted to that, is the track with the little rails that the wheels travel on back and forth for traversing, and then the rack that the gear is connected to drive it back and forth on the track. The mounting brackets are similar but different than on the manual system. These will mount between your frames, one on each side, so that it can mount the extrusion, but also has these brackets on it to mount this cable chain tray too. So this will hold your chain as the unit goes back and forth. This is the power supply that's common to all 3 of the Veo 600 systems. It ships with this power cable. This is your standard computer style plug on the end that goes into the power supply. On the other end are these 3 bare wires. These wires allow you to hardwire into the machine power, or if you want it to plug into the wall, it allows you to choose your plug that's common in your region. Also shipped with the power supply are these 2 brackets. These brackets allow you to take this power supply, instead of sitting on its feet like it is now, to mount it on the back of the machine frame if a customer decides to do that. If we turn this around, we can see that there is a power switch, supply power to the power supply, an option to connect the monitor to the power supply here instead of into the wall or 115. Input for the gear sensor or any other triggering source that we have. The camera, the cable from the camera connects here. And then 1 or 2 monitors. The second monitor is optional. And lastly, if it's a manual with remote or a motorized system, the remote control will connect to this. I'd like to talk about an option on the gear sensor input. A standard system uses a single gear sensor to measure the teeth on a bull gear or on a print cylinder head. This system works fine, but if you're on a printing press and you stop the machine to do a changeover on the roll or some issue with the process, when you start back up, it's possible that the image will not be on the same exact area of the repeat length that you had set it to. So there is a way to do 2 sensor inputs. One is on each tooth that reads each tooth of the gear, and then a second sensor that will read 1 pulse per revolution. So what you would do is you would order 2 gear sensors, and instead of using this single input, you'll have this adapter. I just have ends on it now, but two cables will come into this connector. It'll plug into the same port, and this will give you 1 sensor that's wired into the single pulse per revolution, and 1 wire that's connected to as many teeth that are on that gear. This will save your spot on the repeat length so that each time you start and stop the machine, it'll be in the exact same spot. The 19-inch or 24-inch monitor that we supply with the system will actually be simply a pass-through from the vendor. So with those monitors will be a standard 5-foot VGA cable, which we can do extensions on, which we would do when you size the system. A standard 5-foot power cord with a US style connector. Also with the system though is this power cord that allows the monitor to actually be plugged into our power box directly. So if you send power to our power supply, the monitor can plug into that and you don't have to worry about this non-universal connector. So input devices to the power supply to trigger the strobe. The standard sensor that we supply with a standard system is a gear sensor or pickup sensor that you would mount at the bull gear or a cylinder gear. It's actually an Omron sensor that we splice our cable into. It's this proximity sensor. This mounting bracket is supplied to help the customer mount this near the gear. On the other side is a 15-pin connection that's done at the power supply. Other input devices that we can supply, which are options when you size the system, are, in addition to the gear sensor, a contrast sensor, or the standard KT5 sensor that we use now, sometimes called an IMARC sensor. Can be used to look at images on the web. Our new encoder, so this would be on an axis spinning to trigger the input. Or lastly, not shown here, is just a cable that we call a PLC cable. This has the 15-pin connection on one side to go to the power supply and open wires on the other end, so that a triggering signal can be sent from some computer device, whether it's a computer, a PLC, or some other device, to trigger the strobe instead of it coming off of a gear. All of these cables can be chosen as an option when you're sizing, and the length of cable needs to be specified at the time of order. This is the remote control that's supplied with systems that are the VEO 600-R, which is the manually positioned camera with the remote instead of a keypad on the camera, or the motorized system. You have this connector on one side that plugs into the back of the power supply, and then this keypad does all of your control as far as moving the camera over the web back and forth or up and down the repeat length. It's supplied with this bracket that allows you to mount the remote control to the top of the power supply or to the top of the camera permanently, or it can be removed. There's 2 holes on the back that let you hang it on a hook if you want this to be just a dangling remote, or with a bar that's applied here, this can be a panel mounted remote control, so it's flush with the rest of the machine sheet metal. Don't forget, as with the other devices, you need to pick the length of cable that you need for this remote when you fill out the field survey form. So step 1 is to install the camera in your machine using this extrusion and this mounting bracket that's mounted between your frames. The camera must be mounted 10 millimeters from the surface of the web and be level from the front of the camera to the back of the camera. Once your camera system is mounted into your machine frame, then you connect the camera to the power supply with the camera cable. So one connection here, whether we're going through cable chain or not, and then one connection to the camera input on the power supply. On our little demonstration here, we're using the contrast sensor and to our 15-pin connector. So that goes to your gear input or pickup sensor input here. The supply power to the power supply through a standard computer style connector here. The monitor, which can be mounted sitting on top of the power supply or separate from the power supply, but its cable goes to one of the 2 monitor outputs. And then the supply power from the monitor, we're going to use this cable that's supplied with the system to plug the monitor in to this spot here instead of going into the wall or hard wiring to the machine power. If we're doing a manual with remote or a motorized system, the remote control then, once it's placed, plugs into this top connector here. And your connections are done. So this is the manual camera system with the keyboard on the camera, and I want to go through the keypad layout on the camera and show how those functions are reflected on the screen itself. On the bottom of the display is a menu that shows you what you have the different settings set to. For example, across the bottom we have brighten and darken, and those values, as you change them, are recorded here on the brightness as a reference. Zooming in and out is reflected here next to zoom. You have a 30 times zoom function on this camera. It's divided into 64 sections. So as you, let me turn this to auto, as you zoom in, the zoom will change to let you know where you are, how much more you can zoom in or zoom out. Focus, plus minus, that focus is recorded here under focus. It's just a reference value. A tip for setting up the system is you will want to zoom all the way in, get your 30 times zoom, which is the 64 increments. Do your zoom then so that this image is clear, and as long as you do it at the closest end or most zoomed in value, then as you zoom out the camera will stay focused. As you change the zoom factor, you'll see it change here. You'll also see that the focus factor, it's a compensation for as you zoom out to make sure everything stays in focus, so those values will change. So let me go ahead and zoom out back to 0. Okay. Then we have the split screen function. If I hit this button once, we'll notice as we start here, mirror is in for normal. If we hit the split screen button, this tells us that the screen is now frozen. So even if my web is moving, I'm not going to see it. If I hit that split screen again, now the left hand side of my screen stays frozen, but the right hand side will move to let me compare the different images. If I, while I'm in this freeze mode, if I hit the mirror button, I can then mirror the image so that they will align closer to the two images I want to compare, which is mirroring across X. If I hit it again, it's mirroring across Y. And if I mirror XY, it's basically flipping the image 180 degrees. If I hit that button one more time, I go back to normal. And if I want to get out of my split screen mode, I just hit the split screen button again. And now we'll be in normal viewing mode again. As far as running, right now you'll see that the mode is in auto. Auto means that the camera is going to flash one time a second. It's just going to give you various images across the web. If I hit the mode button, my mode will change to snap. Snap means that the camera will strobe only when an input device like a gear pickup sensor, the contrast sensor, the PLC, or an encoder is telling it that it needs to strobe to catch an image in that part of the repeat. So snap is where you will normally run this system. Now I want to go into the menu structure to show you what is available as part of the system. Again, once you have set up your system, you'll go to gear, hit menu to get into gear, and now my gear value is listed here on the bottom of the screen. I need to enter how many teeth are on the gear that my gear sensor is looking at. So if I hit the up down arrow, that changes the number by tens. If I hit left right, it changes it by ones. Once you have that set and you have the number of teeth on the gear set in the system, you hit menu again to exit out, and again to exit out of the programming altogether. It takes you back to the home screen. So I'm going to go back into that programming by hitting menu, and I want to talk about some of the functions. We have a function called slow. When I enter into slow, I can adjust this number 1 through 9, and what that's going to do is slow down the strobe rate. If it's set to 6, then it's going to strobe every 6th revolution or every 6th repeat length. It just saves life on your strobe. Okay, after I set that, I can go to something called roll. The roll function, right now it says stop, but I can go into these different roll modes, and that is for those applications like small labels where you have multiple images printed on a single repeat length. There's no way that the camera can view all of those. So roll is similar to auto scroll on the old imprint system, but what it does is it automatically cycles up and down the repeat length so that even though the screen looks like it's seeing the same image, you're actually looking at different printed images up and down the repeat length as if you were commanding it to go up and down. So it just means that you're inspecting every print location over time. Plate. If we go into plate function, what this is allowing us to do is if we enter here the diameter of the plate, it will calculate the length of the web that's traveling while the machine is running. So you enter the plate diameter, and using the input from the gear tooth sensor or encoder sensor, it will calculate based on the amount of revolutions and what you said the diameter of the print cylinder is to tell you the amount of web that's gone under the machine. So if we leave it in the screen, they can do that and use that for length measurement. Just an extra feature. Gamma. If I go to gamma, I can turn gamma on and off. This is just a color compensation for your mid level colors. If we're looking at an image that has a small amount of contrast in the color and we have some issues seeing that, we can turn gamma on and it'll help us be able to see it. Generally for, let's say, your foils and shinier materials, you'll want to turn gamma off. We have a CMYK function. If we turn that on, you'll see here that we're actually displaying the colors. And if I use I can use my arrows to move this little square box around. That's letting me see those color specifications in that particular spot. This just allows you to monitor the actual ink color throughout a run. So a nice little feature. We have lastly a function called line, which is just a crosshair. If I want to go in and specify to an operator that you need to be looking at this registration or registered mark here, They just need to know that that's where they need to look, is right there at the crosshairs. So just an extra feature. So we get out of those functions by hitting exit, and then we're good to go. This is a remote control for the manual camera system with the remote or the motorized system. It's very similar to the keypad on the manual system with the keypad on the camera. The buttons are in a little bit of a different spot. Menu still gets you in and out of the programming. The arrows still move you around. When you're in regular run mode, left and right will motorize the camera left and right across the web, and up and down will move you up and down the repeat length like it does on the manual system. The focus in and out, darken and lighten, zoom in and zoom out, those buttons are all the same, along with the split screen and freeze and the mirror and the mode button. It still switches you between auto and snap. The additional button of scan is the only difference. On the version with the manual system, that button won't do anything. On the motorized system, it will actually have you start the auto scan system. Auto scan will auto scan back and forth between the two stops 200 times if you don't hit the scan button again. If you do hit the scan button again, then that stops it. So really, that's the simple version of the remote. It's really the same as the keypad on the manual system, just buttons in a different spot. Here we have the motorized camera mounted on the motorized extrusion. You can see that the camera cable is in a handling chain, which is connected to the camera via this bracket. So once your camera is mounted on the extrusion and the bracket is connected to the top of the camera, then you plug in the camera cable and you're ready to power up the system. Once the system is powered up, then it's time to set the stops. The idea here is that our system is CE rated for EMC certifications. It's also mechanical certifications. So when we want to start this auto scan, we hit the scan button, and now the camera will stop between a reverse direction and with each stop. If a operator was to get his hand between the camera and the stop because it's magnetic, it'll push that off. So now I'd like to kind of just review the installation of the extrusion along with the safety stops. As you can see with this bracket, this is the motorized version. So we have this bracket that allows for the mounting of the cable chain tray. This is just a close-up view of this angled slot that allows you to angle the extrusion so that you can level your camera so that it's 10 millimeters even from the front to the back. Once that's all set up and your camera is loaded, now we can install the stops. So the first one is the magnetic stop for the auto scan. So that's this little piece here with a magnet on it that gets inserted in the slot of the extrusion. And then we have this CE mechanical stop for if the camera does run away because we've knocked off the stop. This just slides in to the extrusion. You put your extrusion back up against your machine frame. Once you put the extrusion back in the bracket, then you want to take this hard stop before you tighten the screw and slide it down up against your machine frame. Once that's set, then you lock down the extrusion and the stop with this screw. And this will give us our CE crush safety standards if an operator has his hand between the camera and the extrusion if it misses a stop because it was knocked off. So this is our soft stop. This is set in place for where you want the end of the auto scan to stop. You lock it down with the set screw and put your stop in place. Okay, now this is where the camera will stop and change direction. But if this was knocked off because the operator had his hand here, his hand would get knocked off across there. If he kept his hand there, this stop is angled so that his hand will roll over the top of the stop and then the camera will stop on this hard stop.